Grade 12s, we are on our 4th day of trigonometry, and we're going to be using the information that we've been working on the last few days and build on today's lesson, angles in terms of x, y, and r again. So recall the question that I ended with yesterday from your homework is that we can use special angles to answer questions with trig and get exact answers. So for this particular problem, I'm asked to solve for x, which is the hypotenuse side of this triangle. I would always start by labeling my sides, and my angle of reference is 60 degrees. The hypotenuse side is the one I always start with, the longest side. The opposite side will be the 8 meters, and adjacent side nobody knows or cares about. So the trig ratio I'm going to use is sine because I have opposite and want hypotenuse. So as we've always set it up, sine 60 degrees equals opposite over hypotenuse 8 over x. Now with special angles and that chart that we have in front of us, that you pretty well memorized, I think, sine of 60 degrees is root 3 over 2 exactly. So root 3 over 2 is the ratio that we want to set equal to 8 over x and solve for x, and we will get an exact answer. We're going to cross multiply, sort of. We're multiplying both sides by 2 and by x at the same time. So we will get root 3x equals 16. Dividing both sides by root 3, we will have an exact answer of 16 over root 3. Recalling angles of rotation and the chart that you have in front of you, we looked at angles of rotation of acute angles, so we would start with our initial arm and rotate to our terminal arm. And we looked at acute angles of 30 degrees, 45 degrees, and 60 degrees. If you look on your chart, you will notice that all three of the trig ratios are positive. Also, your x value and your y value to the right and up, and the r value are all positive as well. R is always positive. But in this quadrant, for acute angles, everything is positive. We also looked at, in the second section of that handout, we looked at a number of obtuse angles between 0 and 180. We looked at angles of rotation of 120. What else did we look at here? 135 and 150. And if you look at your table, you will notice that x is negative. Y and r are positive. And more importantly, in that quadrant, your sine is positive, but the other two are negative. It's not like in Mennonite. Cos and tan are negative. We looked at a number of angles between 180 and 270. We considered, let me just draw this here. We considered angles of 210, 225, and 240. Again, referring to your chart, sine and cos are negative. And tan is positive. Our x value and our y value are negative. R is always positive. Last quadrant. Angles of rotation between 270 and 360. We looked at 300, 315, and 330. Cosine is positive. The other two were negative. In this particular quadrant, your x value and your r value are positive, and your y value is negative. We're going to actually use this little summary in what we call the cast rule. From the last slide, everything was positive here. In this slide, only sign is positive. In this quadrant in the bottom left, tan was positive, and in the bottom right, cos is positive. So our chart refers to where things are positive. All, cos, sine, and tan. CAST, although we start in quadrant 4 for the cast rule, which is a little strange, 1, 2, and 3, the cast rule can help us remember where things are positive. I can't blame misspelling on the smartboard, however. Where this happens when theta is an angle in standard position. So you have your initial arm and your terminal arm. Rotating counterclockwise, and XY is a point on that terminal arm. R units from the origin. So recall, we're going to put all of this together. Sine theta is y over r. Cos theta is x over r, and tan of theta is y over x. With all of that in our head, we are going to answer some questions. So I'm going to draw a grid. I'm going to try and draw a grid. If a terminal arm passes through -3, -7, find sine theta, cos theta, and tan theta. So first thing I want to do is draw it. So my initial arm always starts here. My terminal arm is going to go through -3, -7. So approximately there, very poorly drawn, but picture's worth 1,000 words. Here we go. My terminal arm is going to pass through that point. There is my angle of rotation, and I want to write the 3 trig ratios. Sine of theta, which I don't know its value, is y over r. Oh, hold on. I have my y value, I have my x value, but I don't have my r value. We find the r value by using Pythagorean theorem. I have a little invisible triangle here that has one side 7 downwards and one side 3 across. I can use Pythagorean theorem on the x value and the y value to get the r value. So for my r value, I have -3 squared plus -7 squared equals r squared. 9 plus 49 equals r squared. $58, come on, is r squared. So r, I only need to think about the positive square root of 58. Beautiful answer. So sine of theta equals -7 over root 58. Cos theta is x over r, which would be the -3 over root 58. And lastly, tan of theta is y over x, which is negative 7 over negative 3, which happens to be positive 7 over 3. And remember, in this quadrant, C, A, S, T, this quadrant, the tan should be the positive ratio, and it is. Second one, if theta equals 228 degrees, find sine theta, cos theta, tan theta. So our initial arm, our angle of rotation is 228 degrees. So approximately there is my terminal arm. Theta is 228 degrees. So sine of 228 degrees, cos of 228 degrees, and tan of 228 degrees. We are expecting, based on our cast rule, that the tangent will be the only positive one in this quadrant. We're going to type it into our calculator. It is regular sine button, not shift. It is sine 228. And if you type that into your calculator, you will get negative decimal 743. Cos of 228, negative 0.669. Tan of 228 degrees, 1.11. Tan is positive. If cos theta equals 5 over 13, and theta is in quadrant 4, so 1, 2, 3, and 4. So I'm going to draw it. First of all, we have an angle of rotation that has landed us in quadrant 4. Theta. And cos theta is 5 over 13. So we know that cos theta is x over r, which is 5 over 13. So we know our x value and our r value. In order to come up with the other two trig ratios, we need our y value. Sine theta is y over r, and tan theta is y over x. So in order to find my y value, I'm going to need to use Pythagorean theorem again, that the x squared and the y squared give us the r squared. I have my x value, I want my y value, and I have my r value. 169 on the right side, 25 plus y squared. I'm going to subtract 25 from both sides. Isn't that nice? So my y value is 12. I'm taking the square root of both sides, but hold on a second. We know which quadrant this is in. So we know that my y value is going to be negative. So my answer is going to be negative 12. We can fill out the other two ratios. Sine theta is y over r, that's negative 12 over 13. Tan is y over x, which is negative 12 over 5. Example number 4. If tan theta is 7 over 40 and is in quadrant 3, we would expect that tan would be positive here because it's in the third quadrant. We're going to find the other trig ratios and find angle theta. So angle of rotation, initial arm, we're going to rotate into quadrant 3 just to give us a rough idea, and that is our angle of rotation. So if tan theta equals 7 over 40, we expect tan to be positive here. We have our y over x. But we know that in that quadrant, our y value is downwards, and our x value is to the left. So we know that they're both actually negative, and that's why we have tan theta being a positive number, because we have negative over negative. So the point xy is the point negative 40, negative 7. We need to find our r value to come up with the other two trig ratios. So we have to use that Pythagorean identity. X squared plus y squared equals r squared. Both of those numbers are negative. Negative 40 squared plus negative 7 squared equals r squared. Negative 40 squared, remember, is going to be positive. 1600, and 49 is r squared. R is always positive, so we take the positive square root of 1649. So you can see my picture is quite out of whack. I'm supposed to be 40. To the left and 7 down. There we are. And this has a length of the square root of 1649. But a picture got me on the right track. I'm going to come up with the other two trig ratios. I want sine theta, which is y over r, and I want cos theta, which is x over r. My y value is minus 7, and the r is root of 1649. Leave it in exact answers. It's wonderful. X is minus 40, and the r is root 1649. These three trig ratios can tell us what theta is, and I only need to use one. I am going to choose, oh, what do I feel like today? Let's use the cos. So if we know that cos theta is negative 40 over root 1649, and I want to find an angle, I need to use second function cos of negative 40 over root 1649. I'm going to type that into my calculator. I have an answer of 170, approximately 170 degrees. Does that make sense? That answer doesn't make sense because that would be an angle of rotation here, 170 degrees. Your calculator does not know what your diagram looks like. Only the human being knows exactly what's going on there. So if you have an answer of 170, you know you have 10 degrees in there. Your actual answer is the 10 degrees into this quadrant. So our answer will be 190 degrees. And we're going to check on our calculator. We're going to check left side and right side. Cos of 190 degrees, and we're going to compare it to minus 40 over root 1649. I typed cos 190 into my calculator and I got negative 0.98. It makes sense that the cos of 190 would be negative. Only tan is positive in this quadrant. I typed in minus 40 divided by root 1649 and I got negative 0.98. So we have found the right answer. This little tricky business about this answer not being quite the one we wanted, we'll get into more depth in the next video, but we just want to bring to your attention where things are positive, see, here, all there, sine there, and tan there, and be able to come up with 3 trig ratios when we're given 2 of the components. All right then, pages 5 to 6, numbers 1 to 4.